Okay, so you have just completed your lesson over section 6.1 on Law of Sines. And so now we will proceed to introducing you to Law of Cosines. So we are still solving triangles given certain information, but notice now here at the top that our given information is going to be either 3 sides or 2 sides with an angle trapped in between. So when these are our given information, if that's how we classify the triangle when we do our labeling, you are going to apply the law of cosines. Now, what is encouraging is that we do not have any ambiguous cases in law of cosines. So I know that definitely will bring you some joy. So here are, in this box, some formulas that we have for law of cosines. Now we have a left-hand side column being labeled as standard form, and then we have the right-hand side formulas that is called the alternative form. These are the ones that you would see more often than not, okay? These right here on the left-hand side are what you would use if you are looking for side lengths, okay? So for standard form, I'll write it right over here. This is what you would use if you are looking for side lengths. Okay, these formulas. And we know it's side lengths because notice the lowercase letters. Lowercase letters mean the length of sides. So if I wanted to find the length of A or the length of B or the length of C, I would use these 3 formulas. Well, one of those 3. The alternative form helps you find angle measures. Okay. Now, this alternative form actually is generated from these problems right here. And I'm going to come over here and show you how that works. It's not anything that you need to know or understand how to redo yourselves. I just wanted you to realize that these 3 versions actually are derived from these 3 here on the left. So let's show you how this was derived. So I'm going to write this problem over here. So let me see if I can write this. So we have a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. Okay? Now, notice that they had solved for cosine A. So cosine A is right over here, highlighted, and that's what they're solving for. So what they did is they moved this b squared and that c squared, those are adding, and they moved them over to the left hand side of the equal sign. Okay, so they minused b squared and they minus c squared. So when you move it over this equal sign and rewrite it, the a squared came down, the b squared went over and subtracted, the c squared went over and subtracted, and on this side you are left with negative 2bc times the cosine of A. Okay, again, we're trying to solve for cosine of A, right? So that means I'm trying to isolate it. So if I'm trying to isolate it, I need to get rid of all of this right here. Where all those terms are multiplying, or all these variables and this coefficient are multiplying with cosine A. So to undo that, I would have to divide both sides by negative 2bc, because whatever I do on the left, I must do on the right. And now these two reduce to a 1, canceling. So now I'm left with cosine A being all by itself. But on this side, I have a squared minus b squared minus c squared over negative 2bc. Well, what did they do? Notice over here, the 2bc is positive. So what they did is they just changed the signs here and multiplied everything by negative. So if I multiply all this by negative, I'm going to end up being negative a squared plus b squared plus c squared over 2bc. Okay, so I change the sign, change the sign, change the sign, and change the sign. But notice it isn't that just this. Look, b squared plus c squared is right there. Minus a squared, there's my minus a squared over 2bc. So all I wanted to show you is these are generated from these problems, okay? That's what it is every single time. So that's just a little side note. So let's look here at example number 1. They gave us 21 feet, 14 feet, and 17 feet. Well, just like in law of sines, I'm classifying this as a side, and another side we're given. So when you have a side classification, okay, whoops. That automatically means that you are going to be able to use the law of cosines in finding your angle measures. Side allows us to use law of cosines. So, what are we looking for? Well, we are specifically looking for angle measures. We're looking for angle A, B, and C. So angle A, we don't know what it is. Angle B or angle C, we have no idea what those are. But we know that A is 21. We know that lowercase b, where's the b? Over here, is 14. And lowercase c, angle C, would be lowercase 17. Okay, so don't forget to always look across. Look across. And look across. Okay, so let us proceed. We want to look for angle A. Since we're looking for angles, we're going to use the alternative form. Angle A is in the first problem. Angle B would be the second formula, and angle C would be the third problem. So let's look for angle A. The cosine of angle A equals b squared plus c squared minus a squared. So b squared plus c squared, minus a squared over 2bc, 2, b and the c. Okay, and you can't see what I'm writing, so sorry about that. Alright, so all I did was substitute what I know. Now, I'm trying to solve for A, and just like law of sines, this cosine, in order to get rid of it, I have to take the cosine inverse of both sides. So once I take the cosine inverse of this side, it will disappear, but the cosine inverse on the other side will stay. And I'm taking the cosine inverse of that entire quantity that I wrote. So don't touch the calculator until this last step. So let's grab a calculator. Again, make sure your calculator is in degree mode. Okay. Cosine inverse is always going to be, or arc cosine, if you call it arc cosine, is right here. So I'm going to press the second button, and then I'm going to press cosine to bring up that arc cosine symbol. Okay. Ugh, my glare is really bad. And let's type. So I need to do an alpha y equals to bring up that stack fraction. And I'm going to type 14 squared plus 17 to the second power minus 21 to the second power. And then I'm going to divide by 2 times 14 times 17. And if you want to write times, it also works. And we get 84.69, but because that 69 has a 6 on the side, we are going to round it to 84.70. So angle A, let me raise my paper here up a little bit. So angle A equals 84.70 degrees. Okay, so let's do the same thing for angle B. Let's repeat the process. I'm going to move this to the side. Angle B is this formula. So cosine of angle B equals, pointing here again, a squared. So a squared plus c squared minus b squared. There's my b squared over 2ac to AC. The cosine needs to be get rid of in order to isolate the b that we're solving for. And then we just take the inverse of that really crazy fraction. You will type that all in the calculator, and when you do so, you will end up with 41.59 degrees. Okay. Again, you'll type it just like you did for this one. And as you know, once you have two angles, there's no need to redo cosine angle C, because we know that the three angles must add up to 180. So angle C is merely 180 minus the sum of the two angles that we already know, A plus the B. And so our C ends up being 53.71 degrees. Now here's a thing I do want to draw your attention to though, okay? By the way, that's your answer, and that's all, you're done. But sometimes students, believe it or not, there are students out there that actually prefer law of sines a lot more. So I just wanted to bring it to your attention that once you have found angle A right here at the beginning, you actually can use law of sines right after that. So I'm going to put 84.70 here for a second. You can actually use law of sines to find angle B. So I'm going to write here alternate method just to show you how it does work, that you don't have to use law of cosines the entire time. So because I have those two, I can say sine of 84.70 over 21, which is the side length, equals, I'm going to find sine B here. I'm going to find, angle B. So I'm going to put sine of angle B over the B that I already know, which is 14. And so when I do my sine inverse here to get angle B after I cross multiply it, of course, because you would have to do that and that, right? Notice it will be 21 sine B equals 14 sine 84.7. And then we'd have to divide by 21. but then that sign has to move as well. So my B is the sine inverse of 14 sine 84.7 over 21. So when I put that in my calculator, sine inverse alpha y equals 14 sine of 84.7 over 21, 41.59 is the same answer that we got right here. See? 41.59, 41.59. So just wanted to show you that if you do not feel like using the law of cosines for the second angle, you can for sure use law of sines. They are the same. Okay. Okay. So, I'm going to move this over a little bit because it's driving me nuts. I'm so weird. Okay. So, let's go on to the other side. Example 2. Again, we are highlighting what we have been given. And in highlighting, we classify 15 as a side, 115 degrees as an angle, 10 centimeters as a side. So we know this is a side angle side situation. And side angle side tells us to use law of cosines. So let's use law of cosines. So what was given? Let me write classification here. So our vertices again are angles A, B, and C. Angle A is 115. Angle B was not given. Angle C was not given. As far as lowercase a, b, and c, let's see what was given. This is 15, and it is across from the b. So 15 is lowercase b. Okay, because it's across from the b. The 10 is across from the c. So we'll put that, so we don't know this. So our job is to find this angle, and find this side. Okay? So what do we do? What do we need to find first? Okay? So my suggestion is find your side length first. Why? Well, if I was looking for A, okay, so I'm going to come over here to the front. It's a side length, okay. To find A, I need to make sure that I have the other two sides and the angle in between, okay. The other two sides and the angle in between. So if you look over here, I do have, if I'm looking for A, which is this right over here, I need to have the angle and the two sides that it's trapped in between. Okay, so I'm going to find my A by using the formula a squared equals b squared plus c squared minus 2bc cosine of capital A. I want to show you a pattern before I jump into this problem here. I want you to see the pattern here. Notice how this lowercase a ends with a capital A, lowercase b, capital B, lowercase c, capital C. And whatever it starts out with, it always is adding the squares of the other two sides. B, so it's using the AC. If it's C, it's using AB. Okay, and whatever those two letters are, it's going to be those two letters. AC, there's AC. AB, there's AB. Okay, so what I'm saying is, let's say you have a triangle. I'm totally making this up. Okay, I just want to make sure you understand how to use this formula. Let's say I have an oblique triangle, and we call that R, and S, and T. Therefore, R would be this one, S would be this one, and T would be this one. Okay? So, what I'm trying to explain to you is this. Let's say I'm asking you to find the length of sides. Well, the length of sides are the lower cases. So let's say I was asking you to find T. Okay? So if I'm looking for T, you're going to write T squared equals, well, what goes on the other side? Well, it's always going to be the addition of the other two sides. So if I'm looking for T squared, I need to find the addition of R squared plus S squared. And then I need to subtract minus, I'm going to write it down here because I'm running out of space, 2 times the two letters. And then you always put cosine. If you started with a lowercase t, you must end with a capital T. So let's try it again. If it's R squared would be, well, if R, I'm going to use the other two. It doesn't matter which one you put first, by the way. So T squared plus S squared, or S squared plus T squared, minus 2 times the T and the S cosine of capital R. So pause the video and try and do the next one on your own. I want you to write out the one for S. So pause the video. Okay, so this is what you should have written. S squared equals, you're using the other two letters, so R squared plus T squared, or T squared plus R squared, minus 2RT cosine of capital S. Okay, I better write that on the next line so you don't get confused. I thought I could fit it. So let's put the minus 2RT cosine. If you start with an S, you end with the corresponding angle S. Okay, so that's how this formula works. So let's go back to example 2. Okay, so that's the formula we were just talking about. A squared is what we're looking for. So A squared equals B. We have it's labeled here, so it's 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of angle A. Okay, so you will put that into the calculator. So 15 squared plus 10 squared minus 2 times 15 times 10 times the cosine of angle 115. So notice that this answer is going to be A squared. Okay, so I'm going to write this down, and I'm actually going to say it's the approximate answer because I'm not done. 451.785474. So running into the nearest tenth, I'm going to put 79. Okay, but I'm going to leave this here in my calculator. Okay, I'm going to leave the calculator as is because I'm not done yet. I needed to square root A squared because I am looking for A. So A equals, when I square root this answer, so second, and where's my square button? I lost it right here, squared. Let me raise this up a little bit. So square root is right above this squared button. The square root, and I didn't mean to type that. The square root of what? The square root of this answer, So I type the whole answer in, okay? And I get 21.26. So my A value is 21.26. Okay, so over here, make a note. Don't forget to square root. Okay, always square root on that last step. So now that I have my little a as 21.26, I have a pair of sides that I can use law of sines with. So I'm going to come over here so that I can find angle B. So let's go ahead and do that. Or, you know what, since you guys have been doing law of sines so much, let's practice with law of cosines. I need to look for angle B, okay? So angle B is, what was the formula? Let me write here what you're doing. Find angle B. So you're going to say cosine of angle B equals, right here, a squared plus c squared minus b squared. So a squared is this one right here. And then we have to do plus c squared minus b squared over 2 times, what was it? We're solving for b. So 2 times a and c. So 2 times the a. Where's my a? Back up here. And the c, which is right here. Okay. So now that we have our whole thing set up, we know that this cosine can move over to this side and become cosine inverse. So we're taking the cosine inverse of this entire thing. Okay. So let's type away. Clear this out. Cosine inverse, because we're doing law of cosines, alpha y equals 21.26 squared plus 10 squared minus 15 squared over 2 times 21.26 times 10. You can type it like that too if you don't want to put parentheses. And you get, sorry, B to be 39.73. And guess what? Since you now have 2 angles, super easy to find the third. So B was 39.73 degrees. So let us add those 2 angles and subtract from 180. And when you do that, your C value ends up being 25.7 degrees. As far as example 3 goes, I don't want you to throw away this paper and I don't want you to scratch this out or anything like that. I've decided to push this example problem for unit 7, okay? So we will come back to this problem. So as far as law of cosines goes, we are done up to this problem. Thanks for watching.